So hello and welcome to this session. So this time we are going to discuss now the derivative of a function. As a recap to our previous sessions, we have learned how to deal with functions. Functions in which the independent variable approaches a certain integer. So in short, we have dealt with functional notations. So as for our learning objectives, at the end of the topic, you will be able to relate with the definition of the derivative of a function and then understand the step-by-step procedure involved in derivative of a function. Then of course, we apply differentiation formulas and rules on various functions like basic functions, logarithmic functions, trigonometric functions, and the like. So on the previous topic, it is said that the limit of a function is the backbone of the differential calculus. So as we go deeper, you will appreciate that statement wherein it is the backbone of the subject. So in particular, in this topic, we are going to apply that functional notation and limits in the derivative of a function. So in short, those procedures are involved in the derivative of a function. So to define this is the limit of the ratio of the increment of the function to the increment of the independent variable when the latter increment varies and approaches 0 as a limit. So we can see here if we have a function of x in terms of y, wherein y is equal to the function of x, there is a corresponding increment for y and a certain increment for x as well. So in short, y will become y plus delta y, and x shall incorporate also its increment. So let us term that as delta x. So therefore, x plus delta x. And then from that, we are going to subtract the new formed equation from the original one. Okay, so y plus delta y is equal to function of x plus delta x minus y is equal to function of x. And by this, we will arrive with the function of y or delta y in terms of x and delta x. So delta y is equal to function of x plus delta x minus function of x. And then from this, both sides of the equations will be divided by delta x. So we arrive with the right hand side of the equation. We have the function of x plus delta x minus function of x all over delta x. And then finally, we will let the variable delta x as it approaches 0. So the limit of delta x approaching 0, delta y all over delta x is equal to that function. So that is the derivative of a function. So to translate that in a step-by-step procedure, so the first step is just to replace x with x plus delta x and y with y plus delta y. And then the second step is subtract the original equation with the new formed equation from first step, then simplify. And then the third step, divide both members of the equation by delta x and simplify. And then the fourth step, we take the limit of delta x as it approaches 0 for both sides of the equation. Then we can form a dynamic equation wherein delta x is changing value and it is approaching 0. So what will be the behavior of the dependent variable with a certain change in the independent variable? So meaning what we are deriving here is a function that is dynamic in nature. Okay, so let us now try the step-by-step procedure. So from the equation y is equal to x cubed minus 2x plus 1, so the first step is replace x with x plus delta x and y with y plus delta y. So the left hand side of the equation becomes this, y plus delta y, and then x cubed, just replace that with x plus delta x, and then of course all of the terms are cubed here, and then minus 2 times x plus delta x plus 1, and then the left hand side will remain. For the right hand side, we intend to simplify that and expand the equation. We will arrive with these terms. We have x cubed 3x squared delta x plus 3x delta x squared plus delta x cubed minus 2x minus 2 delta x plus 1. So this is the expanded form of this equation. Okay, so the second step is to subtract the original equation with the new formed equation from the first step and then simplify. Okay, so this is the new formed equation. We just have called that, and then we just subtract from the original equation, which is y is equal to x cubed minus 2x plus 1. So as we can see, y will be eliminated here on the left hand side of the equation. Okay, so the left hand side will be delta y here, and then this is actually the right hand side of the equation. So we have 3x squared delta x plus 3x delta x squared plus delta x cubed minus 2 delta x. So that is the second step. Actually, we have arrived with a function which is equivalent to delta y. Okay, and then the third step, we divide both members of the equation by delta x and then simplify. So simply delta y will be divided by delta x, as well as the right hand side of the equation. All of those will be divided by delta x, and we can see here that the first term now is 3x squared. The second term, one of the delta x was cancelled, so 3x plus 3x delta x plus one of the delta x on the third term will be cancelled, delta x squared, and then minus 2 delta x will be cancelled to the fourth term. And then for the fourth step, we just take the limit of delta x as it approaches 0 for both sides of the equation. So the function limit as delta x approaches 0, delta y all over delta x is equal to 3x squared minus 2. So as we can see, all with delta x will be just cancelled because we just substitute delta x is equal to 0. So we come up with 3x squared minus 2. So with this 4-step procedure, we can notice that the steps are very tedious to do, okay, in essence of effort and time. So therefore, while we notice or recognize such procedure, we also wanted to simplify the procedure by the derived formulas out of that concept. Okay, so we will just have to use these basic formulas for us to derive a certain function. Okay, so number one, the first formula is the derivation of the constant is equal to 0. So derivation of 1 is equal to 0, the derivative of 5 is equal to 0. So any constant without any variable will just equate that to 0. So if we derive that, or the derivative, so d over dx, by the way, is the symbol for the derivative of a function with respect to the independent variable x. So d over dx of constant is equal to 0. So the second formula, d over dx of the first degree variable x is equal to 1. Yeah, the derivative, or d over dx, or parang dx all over dx lang yan, is equal to 1. Okay, for the third formula, it refers to power formula. So the derivative of x raised to a power, say 1 or greater than 1 or 2, or it may involve any exponent, we'll just have to apply nx raised to n minus 1. So meaning, if you notice here, ibababa mo lang yung n, ano? Baba mo lang yung n, then copy x, and then subtract 1 to that n. So as simple as that. You bring down n, okay, you bring down n, copy the exponent, and subtract 1 to that original exponent. So that is how to deal with power formula. And then for algebraic sum or algebraic difference, we'll just have to derive the terms inside the quantity. So as you can see here, the derivative of differential of this function with respect to x is du over dx. So whatever the sign is, plus or minus, just derive the second term, dv over dx. So algebraic sum or difference, just derive each of the term inside the quantity. So in short, we have two terms here. First, derivative of the first term plus or minus the derivative of the second term, plus or minus if we have the third term, fourth term, and the like. Okay, so moving on, with this basic formula also, there might be a combination of a constant and a variable. So what we do is just copy the constant and then derive the variable. Whatever the form of that variable, just copy the constant and derive the variable. So wag kayong malito, sabi natin kanina, derivative of constant is 0, but this constant is having no variable, ano? So this time, itong constant may pares siyang variable. So what you do is to copy the constant and then derive the variable. Okay. So next, what about the product? So the product rule goes this way. The derivative of u times v with respect to x is equal to u dv plus v du. So meaning, you copy the first term, multiply it by the derivation of the second term, and then plus, copy the second term, multiply the second term by the derivative of the first term. So that is the product rule. And then for the quotient rule, we have v du minus u dv all over v squared. So we just treat and follow this ruling. We identify what is the numerator, which is designated as u, and v will be our denominator, and then just follow this formula. So copy the denominator, derive the numerator, minus copy the denominator, derive the numerator all over the square of the denominator. So as simple as that. Okay. So just to expand the power formula, so we can see here that the power formula goes like this. So this is applicable if your term is a single function in terms of that independent variable. However, if we have a linear functions, say u, okay, any function in terms of u that is raised to any exponent, just the same rule, we bring that down, okay, and then copy the function u, and then raise to, just subtract one exponent from that n, and then derive the function du all over dx. So this is very important. Anong pinagkaiba niya dito? Ito, x kasi yan. So kapag dinerive mo yung x, of course that will just be equal to 1. Okay? So dx over dx is equal to 1. Supposedly may 1 dyan dito. Pero hindi na ni-reflect yan. So in this case, the same ruling, but kailangan mo pa rin i-derive yung u. Bakit ganun? Kasi pwedeng yung u binomial, pwedeng yung u that is a radical term, or polynomials. Okay? So on this case, variable lang yan, but in this case, this is polynomial, binomial, or any function. Okay? So that's it for the ruling. We can illustrate that by several examples here. So the instruction is derive the following functions with respect to its independent variable. So all of the functions will be in terms of y, and obviously the independent variable in each of these functions are x. So actually we are getting here the derivative of that independent variable with respect to the independent variable. So the dependent variable with respect to the independent variable. So here we are actually getting delta y all over delta x, or pwede rin itong tinatawag rin na y prime. Okay, so in here for the first problem we have an algebraic difference. Okay, we can see here the algebraic difference. So this is the first term and this is the second term. So the first term is a constant. The derivative of a constant is 0. Okay, and this one is constant times a variable. So this is the constant and the variable. As a rule, derivative of constant times variable is, we just have to copy the constant. Okay, we copy the constant, that is 3, and then we derive the variable. So in this case, the variable happens to be a power function, wherein we know that the ruling on the power function, okay, what is the derivative of u raised to n? That is simply equal to, baba mo yung u, n, copy u, and then subtract 1 from that exponent, and then just derive what is the function with respect to x. So doing that, of course, so 0 na yan, wala na yan. So negative 3, we bring down 2. Okay, copy x, we subtract 1 from 2, so that is 2 minus 1. Okay, and then derive u. Okay, what is u here? U here is actually x. Okay, so what is the derivative of x? That will be equal to 1, or dx all over dx is actually equal to 1. Okay, so finally, the answer for this first problem is negative 6x. So this is the answer. Negative 6x. So 3 times 2 is equal to 6. Okay. So moving on to the second problem. So the second problem obviously is this one. U all over v. So the differential of u over v is actually v du minus u dv all over v squared. So looking at the terms here, this shall serve as your u, this shall serve as your u, and this shall serve as your v. So let's just follow the formula. Copy the second term, which is v. What is that? That is x. Differential of u. Okay. Say d over dx of the numerator, that will be equal to x plus 1 cubed minus, copy the first term, differentiate the second term. So this is x all over v squared, which is x squared. So basically, we'll just copy and perform derivatives here. So further, this d over dx of x plus 1, we bring down 3. Okay, copy x plus 1. Okay, subtract 1 from 3. By the way, I'll just have to highlight here that this is actually u. Okay, yung du over dx is actually dx over dx plus 1, plus 0 I should say, because derivative of 0, parang dinerive mo yung inside term na u. So remember that formula, we perform this, and we also have that one, du over dx. Never neglect this one. Okay, so this is actually du over dx from the formula. Okay, and then minus, we copy that, x plus 1 cube, derivative of x is actually dx all over dx, which is 1. So all of the terms are 1. We divide that by x squared, sorry, this should be v squared. Anyway, this is x squared. We'll just have to copy that here, x squared. So what happened? So this shall combine, becomes 3x, and then x plus 1 raised to 2. By the way, this is just equal to 1, ano? Minus that term, x plus 1 cube, and that's just equal to 1 all over x squared. So finally, we'll just have to simplify this, and then it is just a matter of distributing the exponents or the denominator to the first and second term. So this shall become 3x x plus 1 squared all over x squared minus x plus 1, this is cube, all over x squared. So notice here that one of the x here will be cancelled. Okay, cancel yung isang x dyan. Okay, so the final answer will be equal to 3 times x plus 1 squared all over x minus that second term. So this shall be our answer for number 2. Okay, moving on to the third problem. Again, we have here algebraic sum and difference. All we have to do is to derive the first term, second term, and the third term. So just apply the formula. So dy, by the way, these are dy over dx. These are dy all over dx, or it could be y prime. So the first term, we bring down that 4, and then copy x, just subtract 1 from 4, and then derive this variable, that is dx over dx, or will just be equal to 1. Okay, so the second term, we have a constant, so copy that constant, and then we have here a power formula, so we bring down 2 from that. Okay, so copy x, subtract 1, and then derive the variable that will just yield to 1, and then the constant here is 0. The derivative of constant is 0. So finally, we have 4x cubed minus 4x is equal, and this is actually the answer. Okay, moving on to the next, we have here, say, derivative of y with respect to x. Perhaps you can express that into y prime, or dy over dx. So the first term is x, so that is simply dx all over dx. So again, we have here a constant times a variable. We copy the constant, we derive the variable, and the variable is in terms of u raised to n. Okay, derivative of u raised to n is actually nu n minus 1 times du over dx. So we bring down the exponent, say this is 1/3. Okay, so x, we copy that, and then we deduct 1 from this. So since this is a fraction, for our convenience, we'll just have to use the denominator 3 here. So we'll just say that minus 3 all over 3. And then derivation of u, which is x dx all over dx. Okay. So you can see now that y prime is equal to 1 plus, so this is 2/3 x raised to negative 2/3 times 1. So finally, we have 1 plus 2/3. Okay. Third root. By the way, sorry. Ibig sabihin lang nitong negative exponent is we'll just have to reciprocate that 1, becomes x raised to 2/3. Okay, so anyway, may times 1 yan. So y prime here, 1 plus 2 all over 3 x raised to 2/3. And then y prime, 1 plus 2, 2 all over 3 cube root of x squared. Okay, so this is the answer. Okay, so let us have this another set. For ninth problem, again we have here algebraic sum, so all of the terms will be derived. So starting with the first term, we have 3x, so we just copy the constant. By the way, this is dy over dx, and then derive the variable, so the variable is x. The differential of x is dx over dx, or equal to 1. Okay, so and again we have a constant times variable, just copy the constant and then bring down 1/3 here. By the way, you are deriving now u raised to n, so this is in the form of u raised to n, simply that is equal to n u n minus 1 du over dx. So in this case, we bring down that negative 1/3, so we enclose it in the parenthesis, so to avoid confusion. So again, we copy that x, so copy the original and then less, just have to less 1, so minus 3 all over 3 for the exponent of x, and then derivative of x is dx over dx, and then derivative of this 4 will be equal to 0, or that is simply a constant. So we can now simplify. We have dy over dx, simply 3, so it becomes positive negative 7 times 1/3, or negative 1/3, it is positive 7/3, and then this is x is to negative 4/3, so negative 1 and negative 3 will just combine, so we may indicate 1 here for that. Okay, so dy over dx is equal to 3. So kapag may negative ka nasa taas, ibaba mo lang yan. So 3x raised to negative 4/3. So if you want, you can express that into radical sign. 3 plus 7 all over 3 cube root of x raised to 4. By the way, wala na ditong negative exponent kasi bumaba na siya. Okay, that is equal to 4/3. Okay, so this will be the answer for number 9. So next we have another power formula. So this is in the form of d u raised to n. So nu n minus 1 du over dx. So our u here is actually this inside term here, and this will be our n. So we just have to follow the procedure. So this is dy over dx. We bring down 8 here, copy that one, subtract 1 from 8, say that is raised to 7, and then differentiate u, this one, du over dx. So the first term is x squared, so that is another power formula. Say that is 2x times dx over dx minus 0. So this is the differential of the inside term. Say, I'll just have to indicate this as du. Ito yun. This one. And then, from that, we'll be having now 8 times 2. We have 16. This one, x times x squared plus 3 raised to 7. So this is the answer for number 10. So this is dy over dx. So we have 16x times x squared minus 3 raised to 7. This is the answer for number 10. And then moving on to the 11th. So in here we have a radical sign. So don't worry with the radical sign. It's just simply in the form of power formula. Ito ano lang yan, power formula lang yun. U raised to n minus 1 du over dx. So ang u natin dito, in this particular problem, we have u is equal to x squared minus 9. So yung du natin is derive u here. So this is another algebraic form. We have 2x dx over dx, or this times 1 lang yan, minus u. Okay, so knowing u and du, ano naman yung n natin dito? So our n here is actually 1/2, no? Because square root is equal to 1/2. So in short, this expression can be written as x squared Okay, moving on to the number 12. To number 12, so this is in terms of product, no? U times V. So we know the formula for U times V, derivation of U times V is equal to U dV plus V du. So we just have to follow that one. So copy U, x squared plus 3, derive the way this is dy over dx. Derive the second term. Perhaps we can rewrite this into power form or exponential form. This is raised to 1/2 and then plus v. What is v? Copy that 1 plus 4 x cubed raised to 1/2, and then just derive the first term. You have the first term to be equal to x squared plus 3. So here we copy the first term and then perform the derivation of the second term. So the derivation of the second term, we have 1/2, bring down that, and then 1. Just copy this. Bawas tayo ng isa. 2 over 2. And then derive the inside term. So the inside term is this. The derivation of the inside term is 0 plus 4. Copy the constant, derive that 1. We bring down 3 here. And then we subtract 1 from that exponent cube. And that's it. This is now the first term. Okay, so the second term goes like this. We just copy the second term, I should say, in exponential form. This one now. And then derive the second term. So the second term, first term of the second term is x squared. So derive that. We bring down 2x. Bawas ng isa. This is times 1 or dx over dx plus 0. Okay. So that's it. We just simplify now. Terms, we have x squared plus 3 all over 2. This becomes negative 1/2 na, no? So magiging square root na yan. Dito na lang sa baba yan kasi bababa. Negative means reciprocate. So 1 plus 4x cubed. Okay. What else? The numerator shall be multiplied by this term. We have 12x squared. And then plus 2x times square root of 1 plus 4x. So here we are going to merge this by its LCD. So anong LCD nito? 2. Okay. So this one divided by that is 1. So all of the terms on the numerator will just be copied here. 12x squared plus 3. Okay, plus. So this term will be the multiplier here. So 2x yan times 2 is 1. And then 1 plus 4x. Magdodoble lang. By the way, I think this should become 4x cubed. 4x cubed. This one. So, doble yan, naging squared yun. Okay? So, what happened is that we can now eliminate the radical sign there. Okay? We can cancel that one. So, we simplify the numerator. We'll maintain the denominator, which is 2 square root of 1 plus 4x cubed. So, we have, I think we need to distribute this now. Okay. So doing that, we have 12x raised to the fourth, and then plus 36 x squared. Okay. And then plus, this is 4x actually, combination of this, times 1 plus 4x cubed. So we simplify it further. We have 12x to the fourth plus 36x squared. Again, we distribute this. Plus 4x plus 16x cubed. Sorry. 16x raised to 4. And then we copy the denominator. 2 square root of 1 plus 4x cubed. Okay. Of course, 2 will be a divisor for all of the terms here because we are in algebraic sum. So 12 over 2 is 6. By the way, mas maganda siguro if we try to combine terms first. So we have here equal to x raised to 4, we'll just combine. So 12 and 16, we have 28 x raised to 4 plus 36 x squared plus 4x all over 2 square root of 1 plus 4x cubed. So finally, that 2 will be a divisor for all terms. Magiging 14x raised to 4 plus 18x squared plus 2x all over square root of 1 plus 4x cubed. So this is the answer for number 12. Okay. Moving on to the second sets of problems. For the fifth problem, a while ago we have a quotient differentiation. So this is the derivative of u all over v. Again, this is v du minus u dv over v squared. So we just simply follow the process. Our u here is this one, and our v is that term. Copy v, that is x squared minus 1. By the way, this is y prime. Times the derivative of u. x plus 5 minus copy u derivative of v x squared minus 1 then divided by x squared minus 1. Of course, this is squared. Okay, so we continue by performing the derivative of the inside terms. We have x squared minus 1. So derivation of x plus 5 is dx over dx for that first term and then plus 0. So in short, this will just be equal to 1. Then minus x plus 5 derivative of that inside term for the first term, that is 2x dx over dx minus 0. Okay, so divided by your denominator x squared minus 1, this is squared. So finally y prime will be equal to, so your first term remains to be x squared minus 1 minus, this is 1. Perhaps you can now distribute 2x here. On the first term becomes 2x squared plus 10x. So we divide this by your denominator equivalent to x squared minus 1, and that is squared. So we simplify the terms further. We have x squared minus 1 minus 2x squared minus 10x all over x squared minus 1. This is squared. So x squared will combine with negative 2x. So it becomes negative x squared minus 10x all over x squared minus 1 raised to 2. So I think we should include minus 1. So I think this will be the answer for number 5. Okay. So for number 6, we will express the function in terms of exponential form. This is raised to 1/2. So dy over dx, we consider this as u. And of course, this is just in the form of u raised to n minus 1 d. Okay, so we just perform that. We bring down 1/2, copy that u, 1 half minus 2 over 2. Differential of the inside term, 0 minus 3 times 2 x. Ilagay rin natin yung dx over dx. Hence we have here dy over dx is equal to 1 6x negative 6x all over 2. So ito negative 6x yan. So negative 6x divided by 2, ito yung 1 half. And then bababa na yan kasi negative 1 half na yan. Actually that is square root 2 minus 3x squared. Perhaps you can cancel that. 6 over 2 becomes 3. 2 minus 3x squared. So this will be the answer for number 6. Okay. Next one. Number 7, this is in terms of differential of u times v, or this is equal to u differential of v plus v differential of u dv plus vd. So we just simply follow the process. So this is dy over dx, copy u, derive this. So perhaps we can derive it right away. Derivation of 3 is 0 minus 2x, copy constant, derive x, that is dx over dx. Okay, and then plus v, copy v, 3 minus 2x, derive this first term, 0 minus dx over dx. Finally, dy over dx is, we have negative 2 times 2 minus x plus negative 1, this one, times 3 minus 2x. So we distribute, this becomes negative 4 plus 2x minus 3 plus 2x. So therefore we have here y prime, or dy over dx, starting with x. This is 4x. 4 and 3 will just combine into negative, or x minus 7. So this will be the answer for the 7th problem. Okay. So for the 8th, again this is algebraic sum. So we derive it right away. We bring down 3 halves, copy that one, subtract 1 to 3 halves, okay, 2 over 2 yan, plus 0. So dy over dx is equal to 3 halves x raised to 1 half. or we can write this as 3 halves square root of x. So this is the answer for number 8. So these are preliminary examples. So please stand by for more sets of examples regarding the derivative of basic functions. So I think you need to practice and have a good day, class. Thank you.